All right, we'll be getting into the reactions of alcohols, substitution reactions. General formula for balancing an alcohol, it's expected that you can do that without memorizing a formula. Hopefully that would be true. Okay, so as an example for combustion, ethanol. It's used as both a solvent and as a fuel. It combusts completely in excess oxygen to produce carbon dioxide and water. And this would be the equation of the complete combustion with the products carbon dioxide and water. You can see the change in enthalpy is pretty high. Right? It's already partially oxidized, so it releases less energy than burning. An alkane of comparable mass, that should be N-alkane. However, it can be obtained by the fermentation of biomass. So in some countries it's mixed with gasoline to produce gasohol, and it helps us decrease the dependence on crude oil, the Middle Eastern companies. All right, and here's just a cartoon. And another one. So let's talk about the actual chemistry, the oxidation of ethanol. In these reactions, ethanol can be readily oxidized by warming with an acidified solution of potassium dichromate. Okay, this is going to be the oxidizing agent. Okay. In the process, the orange dichromate ion is reduced to form the green chromate 3 ion. So the oxidation state changes from a +6 to a +3. The color of the solution goes from orange to green. It is important to note this color change from the beginning to the end. Another oxidizing agent that you should be aware of is the MnO4-, the permanganate ion. Permanganate ion. And in solution, this will be a deep purple initially with a +7 oxidation state going to the pink +2 or +2 oxidation state. Okay, the book centers on the dichromate ion, the Cr2O7-2, but it is worthwhile. You might get a point or two remembering that the permanganate ion is purple and it goes to pink when it changes its oxidation state to a +2. These are used in the breathalyzer test, as shown here in the little picture. If the orange crystals turn green, there's a lot of ethanol. There's a story, you can read it, about a guy who beat the breathalyzer by eating his underwear. Not exactly sure the chemistry. Maybe it just absorbed the extra alcohol. All right. Ooh. When we look at the oxidation of alcohols, okay, and this is partial oxidation. Complete oxidation is the combustion of the alcohol. But we're going to be looking at types of reactions, and the first one is ethanol being reacted in the presence of that dichromate ion and acid, so an acidified dichromate solution, and this is going to be under conditions known as the under distillation. Okay, so there is also heat, and we'll talk a little bit more about the experimental setup. So this ethanol in like this first stage goes to the aldehyde, and then if we continue to react it under conditions known as reflux, and we'll talk about that in just a minute, there's heat and there is reflux, it will further oxidize the aldehyde into the carboxylic acid, and in this case ethanoic acid or vinegar. So What's important to note about these reactions is that a primary alcohol is going to react under an acidified chromate solution with heat to the aldehyde. If I run that reaction further in the same acidified dichromate solution with reflux, I'm going to convert it to the carboxylic acid. And this is for a primary alcohol, meaning a hot alcohol where this alcohol group, the OH, is connected to a carbon with at least 2 hydrogens. And this is a primary alcohol. Okay, so it's important to remember the conditions. Distillation, and this is with distillation. And then with reflux and heat. So the first step makes the aldehyde. The next step, continuing to react, makes the carboxylic acid. Now, so we're kind of stopping this at the aldehyde stage, at the ethanol stage. And what we need to do is take off the ethanol to distill it, okay, from the reaction mixture as soon as it is formed. This has a lower boiling point, so it's going to go into the vapor state more readily than either the ethanol or the ethanoic acid. So what happens is, for this distillation, I have, sorry about that. This is the distillation and taking that primary alcohol to the aldehyde. I have a round bottom flask, a heat source, a thermometer, and then this condenser, which is really just a glass tube within a glass tube. So the ethanol, the aldehyde, boils at a lower temperature, so this comes off first. Okay, and it travels down this inner tube. It cools and it travels down this inner condenser. In the outside glass container, we run water. So water is running through here, cooling this down and making it into a liquid, which is then collected. But the aldehyde is the first thing that comes off when we're boiling that. What we do is that aldehyde is still going to come off or boil off soon, but we hold the condenser upright so that the aldehyde, with the cooling water coming in this outer glass, okay, and this is still your water, but your aldehyde recondenses and falls back down to further react in the reaction mixture in the round bottom flask. Okay, so it just keeps it there longer, more in contact, as opposed to boiling it off and condensing it and collecting it and taking it out of the system, giving it less time to convert all the way to that carboxylic acid. Okay, so all primary alcohols are oxidized with that acidified dichromate under distillation. Okay. And then you can take that aldehyde further if you basically keep it in contact with the reaction mass through a reflux column to make the carboxylic acid. So this happens to all primary alcohols. Secondary alcohols are pretty much the same reaction conditions, including that reflux. I believe it includes the reflux, making that secondary alcohol, meaning it has only one hydrogen connected to it. The other two branches are some kind of chain carbon with that dichromate oxidizing agent acidified with reflux goes and makes the ketone. Tertiary alcohols cannot be acidified. tertiary have 3 branches, so that carbon is connected to 3 other carbons and the alcohol group, and it can't be oxidized by acidified dichromate ion, and they really can't be I guess partially oxidized, only completely by burning them. Alright, but when they do that, the carbon chain is completely destroyed, and if you have complete combustion, I would end up with carbon dioxide and water. Okay, next we'll talk about the halogenoalkanes.